Now that the first version of this app has been deployed and checked into source control, we can continue with the refactoring. Effectively, we're just going to move the strain VM into its own TypeScript file like we did before. Alright, so now we can just start pulling the properties over. Okay, so we have the properties copied over. Now we can start bringing over the functions. So now the function's been moved over. You'll notice a few things have changed. Firstly, in a couple places you'll notice I had to change from dot notation to the indexer notation, because payload does not actually have a property when we first created the object, so TypeScript's going to tell me that's not a valid property. But using this syntax, it kind of treats it as any and says just trust me. Same here for the data. I couldn't do .data equals, and the data object changed because I didn't want to change all of the data object .page equals this to data object index page equals this. So I just converted it to directly create the literal inline. And then the other thing I'm doing is returning the Ajax with my continuation on it, so that if someone else called this, they could attach another event if they wanted to. Now this isn't necessary because, as you'll see in a minute, when we update the result table, that's pretty much as good of a signal as any that something that this function has completed, and it gives you the data. Now you'll see we have one error, or supposed error, that the $ is not defined, and that's because we haven't added jQuery's typing definitions to our project yet. So to do that, we're going to go back into NuGet. So now we can see that the error for the $ is gone. However, now we have an error saying that this payload is not valid. However, it is, so we're just going to tell it trust me on this and put an any in here. Now, since we have the type definitions available, we can say that this function is actually going to return a promise. And right now we'll leave it as it'll have some data in there, but we don't want to figure that out right now. So now let's just pass through the result. And the view model has been extracted. And we have to include it after its dependency of the Leafly credentials view model. And you can see the refactoring didn't break anything. It still works as it did before. So now that the strain search page is more or less working, we should look at how to hook up the filters. And we can see in this search object, like we saw earlier, the sort options, the facets, which would be a lot of these items in the multi-select, such as this is a tag. This is also a tag and it's energetic, so we can parse through the facets, split them up into tags, conditions, categories, symptoms. We have a display value and the tag's ID, which is this value that we actually need to supply if we're going to filter on it. At this point, I'd like to look at creating some sort of library that will help us interact with Leafly, since they don't provide one for us. So one of the things we can do in TypeScript is declare a module. Kind of think of a module as almost like a namespace. So everything in this file is going into the Leafly module or Leafly namespace, so that we know all of these functions and classes are going to help us query Leafly's API. So one of the things I've started to really like to do when I'm constructing these types of applications where we're going to be querying for data and getting some sort of response back is to have request and response objects. Now we know every single request to the Leafly API is going to require the app ID and app key, so I'll just create some base request type that ensures that those two pieces of information are present. Then we're going to create the string search specific request object. This object requires a page and a take. You can specify a sort, a search term, and filters. So now we have a request object, and we need something that can actually take that request, call Leafly, and return some results for us. So I'm going to create a class that will handle just requests to the /strain endpoint, and we'll have another one that will handle all the requests to the /location endpoint. So the shape of this function is going to be give me a request, in this case a string search request when we call the search function, and give me back a promise with some data. So the return from a search request is an object with these properties. So I'm going to go ahead and create the response object from the search request. To create this class, I'm just going to add the properties one at a time. So we have facets, and the type is an array, and for now let's just say it's any. There's a location filter Boolean property, a location URL string, a paging context object, sorts, and this is an object that lets us put the sorts into an array so that we can have a nice display label. And strains. Now because this is going to be the return from the server that we're just going to consume some JSON and assume that it has this shape, we're not actually going to export a class. We can set this as a type. And then I can create types for each of these any objects. Unfortunately, this response object is fairly complicated and several of these types have nested types in them. But effectively, I just translated all the messages into their appropriate objects. So now we have our response type available. we can go back and update the API to include this as the response type instead of any. This strain API now has the responsibility of translating this request object into whatever it needs to eventually call Leafly's API and give me back a strain search result. Now we're going to go ahead and use Ajax like we did before, and I'm going to go through some examples of how you could do this, and we're going to refactor out and look at some better approaches, so bear with me while I go through some different approaches to solving this problem. So one way is we could just put the Ajax formatter here directly in this API, so I could have a private method that formats strange search request objects into jQuery Ajax settings, just like we had before. Then all we have to do is call the Ajax function on jQuery and pass in the formatted strange search request. It'll treat it as Ajax jQuery settings. And since the return from an Ajax call is any that satisfies the signature, we're just going to assume that the response does fit this shape since it is what it's supposed to return to us. We don't actually have to do any parsing or construct a class back out of that JSON. We're just going to use it as it is. So we can go ahead and see if this works. So we'd add the Leafly module we just created to this page as a dependency. The Leafly module should not depend on anything that we're working on. The scripts that we're working on should use the Leafly module. So we can go in and update the strange search view model. Instead of doing all this work in here, we can take advantage of what we've already done. So first, we know that we can update this return type to a strange search response. And here we can just call the API. So now this view model doesn't have to do really any of the heavy lifting. It just has to request a new search object and pass it through to the search function on our API. So far, while creating this sample website, the strange search has been approached from a UI first perspective, where we created the UI to kind of describe the intention of what we were trying to do, meaning we knew we needed all these inputs to eventually construct a request and fire that request and get a response. Now that we've seen some examples of how to refactor that UI into view models and how the view models get hooked up to that UI, we can continue into the location search using a code-first approach, where we're going to develop our view models and later bind our view models into some view that will be created. So let's go ahead and implement the strain details. So the details method is going to take a strain details request and return a strain details response. Luckily, this request object is a lot simpler and just has a slug that we get back from the strain search. So this is just a string property. Now that we have the request, we can create the response object. Just like before, this is just going to be a type. And to figure out what the response object actually looks like, we'll go ahead and make a call and just investigate what comes back. So we'll fill in the details method itself. So the two parts are formatting the details request, calling the AJAX, and getting that response back. In this case, the payload's also a lot simpler because we're just performing a GET. There is no body that we can post data in. So the URL contains the slug now. So we have strings / the slug for the details that we want. So now we can see in the result from calling the string details API and passing a string details request, we get this response object. So just like before, I'm just going to copy this response object and all its properties into TypeScript so that we can just consume this as a type. So now we have the response object for the details request. This object also has quite a few things in it that seem pretty questionable, but I just converted all the types over so that we could consume it with some type safety on our end. At this point, we could continue adding methods to this class to match the available methods in the Leafly API. However, we can start to see a pattern forming. The next method I would be adding would be the reviews method. And in order to satisfy this method's implementation, I would also be adding a formatter. When we implement one of these methods, like the details method, this class is responsible for taking the request object and returning a promise that will eventually resolve in the string details or string search response object. This class should not be directly responsible for formatting or using the formatted object to actually dispatch a request and handle the response. Here we're using jQuery's AJAX to perform the actual request and give us back a response, just like we should be using something else to format the request into an appropriate argument for the AJAX call. So typically I look at formatting objects as a standalone responsibility, converting from some data request base into a jQuery AJAX settings. Seems like something that should be done in its own class. So again, I'm going to go through some different stages of how you could do this and refactor out a good solution, so just bear with me while we kind of look at a few different approaches. The first approach is just to create a simple class that can handle the formatting. One way would be to just have a static method that formats the request and does this. Then we could have another method and we could refactor out some commonality or even take advantage of some of TypeScript's new features where we can say or the request is either a search request or a details request, and then we can do some switching. Using the instance of operator, I can test and see if this is a details request and adjust the URL. You can see this cast that I did above is not actually required because inside of an instance of check, it can tell that this actually is this type. So I can go ahead and just get rid of that. And that's pretty nice. Though while it is nice, it kind of violates the open-close principle, where every time we have a new request show up, we have to actually modify this method and chance breaking code that was working for an unrelated request type. So typically I would put this behind an interface. So here we have an interface for Leafly request formatter of T, where T is the resulting format that the request will transform into. To make this more robust, we're going to add the canFormat method that can test to see if a request object can actually be formatted by the implementation. So now each one of these types that's in the OR would get its own class, and that class would implement this Leafly request formatter. So the strange search request formatter checks to see if the request is an instance of strange search request for returning true for canFormat. And in the format, of course, we should test if we can actually format the request. And if we can, we'll format and return. So we see the type of formatting is jQuery Ajax settings. Now that we have the formatter, we can remove the methods that were doing that work. Now that those additional methods have been removed, this class turns out to be pretty simple. And like we talked about, each one of these methods is just responsible for formatting the request into an appropriate transport object, and then Ajax will send out the request, come back with a response, and we're going to treat that response as the type that we're specifying. So I'm going to add the rest of the request types and the formatters. Now that the additional requests and formatters are available, I can go ahead and add the rest of the methods. With these additional methods, though, we still don't have the return types mapped out, so we're just going to leave them as any for now. Now that all of these methods have been implemented, we can see that the pattern is pretty clear, that we just need to find a formatter that can handle the request and shoot it off to Ajax. We don't actually need to do anything with the response. So you could take this a step further and say, so here we could just specify a list of formatters and then specify any request object and have it send it off and assume that the response comes back as whatever type we asked for. This would allow us to have additional requests in the future without having to modify the strain API. However, it is kind of a mirror for a published public API, so going this far may not really make sense. However, as we'll see in a little bit, it does make the code potentially more readable and less redundant to use this request method and specify the request type. So one other thing we can see is that I was just inlining a new formatter each time for speed. That's probably not the most optimal way of doing it, so one of the things we can do is actually declare a static on these classes and kind of make it like a singleton without being able to actually make it a singleton. So I can declare a static instance that is a new instance of the search request formatter, and then below I can refer to that instance. And I can update the rest of them to do the same thing. And now all of the requests use the instance of the formatter instead of newing up a new formatter each time we fire a request. Now the other thing that will get annoying after a while is as we call these methods, we're going to be creating new instances of these requests, and the first two arguments for all the requests are always the same, the app key and the app ID. And to have to keep supplying them when it's likely they'll never change for the lifetime of the application, that seems like a good opportunity for refactoring. So typically I like to create a factory in this case, where if we have some set of parameters that we want consistent across all the requests, we can initialize a factory with those parameters and then supply just the details that are different between the requests. So I'm going to go ahead and add a factory now that can generate these request objects. So here's the request factory for all the string search request types. You can see that when we construct the factory, we're going to specify the app key and app ID one time. And some of these methods have an optional page intake if there's multiple pages. By default, the 0 page is used and 10 is the default take. I just decided to throw that in here anyway. It's something that we could specify to use consistently. Use this take default if it's not specified instead of the default on the server, which is 10. And if you don't specify a default, the take default is 10, which is Leafly's default as well. Using this request factory will make it a lot easier to just specify the pieces that we need for the request. So for instance, a details request now only needs the slug. The string search request, all the parameters are optional. Typically, the most likely parameter to be specified would be the search term itself, so we can also order these parameters in a way that makes the most sense. Now that we have the factory and the API available, we can go ahead and use it to actually map out the return types. So we can create a factory and use the local storage to initialize the app key and app ID, and create a new API object. So we can call the reviews endpoint, specifying we'd like the Blue Dream reviews, and then just write the result into the console. And now we can create the return type pretty simply, just like we did before. So there's the string reviews response. Pretty simple compared to all the other types so far. And using one of the details that was returned above, I saw the ID was 462066 for Blue Dream, and requested the details of that review and just logged them into the console. So I can create the response type for the review details now. So now we have the string review details response type available. We can keep adding the rest of the response types. Now, one of the things I talked about before was the potentially redundant specification of what we're requesting. Here, the API method name is review details because that's what we're requesting, but the request object is also the string review details request. It should be pretty obvious what the request is, and we shouldn't necessarily have to specify it from the API. So we have this request method that we can use instead, but right now we know we didn't actually specify any formatter, so I'm going to go do that. This syntax removes the ability for me to provide the wrong request object to the method. For instance, the search method can only accept string search requests. This method can accept any type of request as long as there's a formatter that can handle it. And this is why I believe it improves the readability of this API. I'm just sending a request for a string picture of Blue Dream. I don't have to match the method to the object type. So now we have the pictures response, and I'll just add the availability response. So just like before, in order to get the response type, I'm just going to run the API. Now the string availability request requires the latitude and longitude that you want to look up the availability for. And of course this response has to be an array and not an object. Now that we have all of the response types, we can go back and update the API to return the appropriate types. And at this point, we have an exact replica of the Leafly API for strains, and we can move on to creating the same type of API for the locations. To create the location API, of course, we're going to first add all the request objects. So we have a search, details, menu, reviews, and specials requests for locations. Then we'll add in all the formatters for these requests. With the request formatters and the request objects, we can quickly throw together a similar looking API for locations. Now that we have the methods on the API, we can actually call these methods to map out the response types, just like we did before. Now that we have all the response types available, the API looks complete. At this point, we can see something kind of emerging where all these methods have location prefixing them because, for instance, there are two search methods. We could prefix these all with strain or just leave these as special, but at this point it seems like a good idea to split these up. With the API split up, it made more sense for the API, instead of taking a request object, to take the parameters for the request. Keeps it a little bit simpler in terms of using this API, and internally have the factory create a request object and a formatter to format it. I also created an external wrapping API that provides a way to segregate the location API and the strains API so that we don't have to prefix anything. So using this API would look like new Leafly API, pass in the app key and ID, and then you can use the locations and strains API as much as you want using that app key and ID pair. And then we still have the ability to make requests with just calling a request method by pulling out this request manager. If I wanted to only handle a few types of requests, I could put only a couple formatters in there and just call request, or create my own formatters and do whatever. So this allows me to still use that approach if I'd like, or I can use this kind of typed out method-based approach, and we remove the chance of passing in the wrong search parameter object because now the parameters are directly in line with the method. So at this point we have what I would call nearly a V1 API wrapper. There are some types that I couldn't figure out just because nothing came back from the server. So for the most part, this is complete.